Now, class 12 student, today I'll continue with second order derivative, the proving sections that we'll do, concept we did first video of second order derivative. Now the question given, if y is equals to 5 sine 4x, prove that d2y by dx square is equals to minus 16y. Now sir, since y is equals to 5 into sine 4x, now first of all that you have to calculate the first order differentiating with respect to x. Now dy by dx is equals to 5 into the derivative of sine 4x is cos 4x into the derivative of 4x, 4 and derivative of x is 1. Now we have dy by dx is equals to 5 4s are 20 cos 4x. Now this one is the first order derivative. Again differentiating with respect to x. This is d2y by dx square is equals to 20, and now the derivative cos 4x is minus sine 4x into derivative 4x is 4 into 1 minus 4 into 20, it is 80 sine 4x. But what you have to prove is d2y by dx square equals to minus 16y. So I'll write d2y by dx square is equals to, now we can write minus 16 into 5 sine 4x. 16 into 5 is 80. Now in place of this 5 sine 4x, the value of 5 sine 4x is y. Therefore we can write d2y by dx square is equals to minus 16. In place of 5 sine 4x we can write y. This is equals to, it is proved, d2y by dx square is equals to minus 16 y. Now another problem, y is equals to a e to the power minus kx minus b e to the power minus kx. Prove that d2y by dx square is equals to k square y. Since y is equals to a e to the power minus kx minus b into e to the power minus kx. Now from this expression, now we can take e to the power minus kx common. So it will be a minus b e to the power minus kx. The y is equals to this much. Now then I'll calculate the first order derivative. Differentiating with respect to x. Now it is dy by dx is equals to a minus b into derivative of e to the power minus kx is e to the power minus kx into minus k derivative of x is 1. Now we have first order derivative is equals to minus k a minus b e to the power minus kx. This is dy over dx. Again differentiating with respect to x. The same thing that you have to do in case of second order derivative. Minus k a minus b, the derivative is same. E to the power minus kx will be e to the power minus kx into minus k derivative of x is 1. Now then we have d2y by dx square is equals to minus into minus plus k into k, k square, a minus b e to the power minus kx. Now k square, but what you have to prove? d2y by dx square is equals to k square y. Now this whole quantity a minus b into e to the power minus kx, a minus b e to the power minus kx is y. In place of this we can write y. It is proved. Dx square is equals to k square. Now student, this is another type of problem. Y is equals to tan inverse x, so that 1 plus x square d2y by dx square plus 2x dy by dx equals to 0. This you have to prove. Now since y is equals to tan inverse x. Now differentiate this function, differentiating with respect to x. Now it is dy by dx. Now the derivative of tan inverse x is 1 by 1 plus x square. Now sir, in this question, the first order derivative is in terms of numerator over denominator. From such kind of numericals, what you have to do next is to get the second order derivative, you have to cross multiply, then use formula. Cross multiply this one will be 1 plus x square dy by dx equals to 1. Now then, I'll use product formula, u into v form. 1 plus x square is considered as u and dy by dx is considered as v. Now differentiating again differentiating with respect to x. Now it is 1 plus x square u dy dx of dy by dx u dy dx of v plus v dy dx of u 1 plus x square equals to, now the derivative of right hand side, it is constant and that is equals to 0. Now 1 plus x square into dy dx of dy by dx is d2y by dx square plus dy by dx into derivative 1 0 plus derivative x square, it is 2x equals to 0. Now then, therefore, now it is 1 plus x square d2y by dx square. Now then, dy by dx into 2x plus 2x dy by dx equals to 0. It is proved. This identity is proved. Now dear student, in this question, this section is a little bit different. 1 minus x square y2 minus x y1. You may get this question in this form also. Or 1 minus x square y2 means it is d2y by dx square minus x y1 means dy by dx equals to 0. But I'll use this notation since y is equals to cos inverse of x. Now differentiate this one. So differentiating with respect to x. Now instead of writing dy by dx, now I'll write y1. The first order derivative y is, actually it is dy by dx, but according to the given notations, it is in terms of y1 and y2, so I'll write first order is y1. And the derivative of cos inverse is minus 1 by under root 1 minus x square. This question is also in terms of the first order derivative is in terms of numerator over denominator form. So cross multiply and try to prove this relation. Cross multiply this relation. 1 minus x square into y1 is equals to minus 1. Again, differentiating with respect to x. Now use u into v formula. U dy dx of v plus v dy dx of u under root 1 minus x square, and derivative of minus 1 is 0. Now it is 1 minus x square into dy dx of y1. That means dy dx of dy by dx is d2y by dx square. Instead of writing d2y by dx square, I'll use derivative of y1 will be y2. This one is the second order derivative. Plus y1 into the derivative root. Root means 1 over 2 under root 1 minus x square into derivative of 1. 0 minus derivative x square is 2x equals to 0. Now after simplification, now we have under root 1 minus x square y2. Now this one minus into plus minus, so we can write 2x y1 divided by 2 under root 1 minus x square equals to 0. 2 to get cancelled. Now then I'll take under root 1 minus x square LCM. If I take under root 1 minus x square LCM, under root 1 minus x square into under root 1 minus x square will be 1 minus x square, then y2 minus x y1 is equals to 0. Then cross multiplications that you have to do. Therefore 1 minus x square y2 minus x y1 is equals to under root 1 minus x square into 0 is 0. This is true. Now this much we'll do today. Now next video I'll do some tricky questions and some important questions of second order derivative. Thank you.
दोइलो खन्दै मैसिन बाहिर जान्छु